Hello and welcome to today's episode of Rawkode Live. I am your host, Rawkode. Before we get started, here's a quick reminder that you should subscribe to my channel at Rawkode Live and click that bell. That means you're going to get all of the updates, and there are multiple streams per week, so hopefully there is content there we can all continue to learn this vast cloud-native landscape. Also, be aware that we do have a Discord chat. Please come and join us. The conversation is always fun, and there's lots to learn from everyone involved there too. So cool, get involved. Now, today we're going to attempt to write a Kubernetes controller to satisfy a random idea that I had in December last year. We'll talk a little bit about that in just a moment. But I am not smart enough to write my own Kubernetes controller, so I've solicited some help from a friend of mine, Suhail Patel. Hey man, how are you doing?
Hello, great to be joining you. Thank you for the invite. Yeah, this will be fun.
Oh, I don't have too many buttons. There we go. Yeah, I'm really looking forward to this. I have written Kubernetes controllers before. I think you've got way more experience than me here, so maybe we can. We'll do introductions first, but maybe we'll talk a little bit about the different ways to extend and modify Kubernetes and give people a little bit of insights and flavor into how that works. So let's start first with you. Why don't you give us the Suhail pitch?
Hey, thank you. Hi, my name is Suhail. I am a software engineer. Currently, I work for a company called Monzo, where I help build a better banking experience. I've been using Kubernetes for a number of years now and been involved with the CNCF ecosystems of software, so things like Prometheus, Jaeger, and all of these other tools, Kubernetes, Envoy Proxy, and all of the other tools that are involved in the CNCF ecosystem. Essentially, I want to make infrastructure I want to represent infrastructure from an end user perspective. Getting involved from within the end user community and stuff like that.
Awesome, very cool. All right, so Kubernetes controllers, what are they?
So think of a Kubernetes controller in the sense that you with Kubernetes you declare what you want, and the Kubernetes controller does all the actions necessary to take what you want done and actually make that reality. Essentially, if you create a deployment, in Kubernetes, you specify lots of YAML, and you might specify like a deployment object. It will take that and it will then essentially process that, see the state of the current cluster to see, for example, if that object already exists with that particular name. It takes what you desire and gets it to the end state. So, for example, in a deployment, it will take the number of replicas. It will create the replica set if necessary. It will pull down the image and it will create the required pods. It will do everything that is necessary to satisfy what you declare, essentially.
All right, and I mean, everything. Is it fair to say that everything in Kubernetes is a controller as it is just now?
Pretty much everything, yeah. A lot of the common objects that you interact with, such as deployments, replica sets, all of these standard Kubernetes objects are essentially controllers, and they're getting down to the lowest level Kubernetes abstractions, which is things like pods and containers to the very end. So essentially, everything is like layers of manipulation between to get to a state where you have pods and containers running in your cluster.
Okay, cool, very cool. All right, we have a couple of comments, so let's get them on the screen, and then why don't you and I just talk about the problem that we want to solve today, and then we'll talk about the different ways that we could potentially achieve that then. So Vignesh, welcome back. Hello. We have a excited. Yep, I am excited too, that's for sure. And a hi from Moz. Hey, hi Moz. I'm not sure why that font is colored black. I'll fix that later. Okay, so when we chatted about doing this, we had a rough idea that what if, in fact, let me throw this back. I wish I had the foresight to find this tweet, and maybe I'll try and find that in a second. But I think it was in December, I tweeted an image where I had taken I had taken the image tag within a pod spec and made it look a little bit weird. And what I did was put the image name, and then for the tag, I actually provided like a semantic version constraint. Maybe that's best visualized actually. Let me pull up my screen share. So assume this was a pod, and then the image, Nginx, and I think what I had was like greater than, let's say, come on, VS Code, something like this, where it's not valid, and that this is not a correct image name or tag, and this has no semantic meaning within a Kubernetes cluster. There's no way to really tell what this means. There's no way to really, I mean, this would just fail, right? Yeah, because it wouldn't be able to pull a tag. So what if we could write something in the Kubernetes land that would notice this unique syntax for the image and then resolve that for us at runtime and update our pod spec? Does that make sense?
Yeah, absolutely. So this was quite interesting because from this tweet, I actually gave this a shot to see how far you could get. Whether even Kubernetes will accept this as like valid input. So
It
for example,
does.
if you put this into your YAML,
Yeah.
it does, yeah. I was quite surprised. I thought it would immediately complain because it's not a valid image name. But because it does accept it, that means it is storing that somewhere. So it's storing that state in the Kubernetes storage system in etcd. So for example, we can then essentially extract that and manipulate it to convert it into something that is usable and that will essentially resolve and run on our cluster.
Yeah. So is there more than one way for us to make this work?
Yeah, there's actually a multitude of ways. So what we could do, for example, is we could say that we want to go completely custom and we want to write a custom controller that will look like a deployment. For example, we might give it a kind of like a version deployment and that would take or like a versioned pod, for example, that would look exactly like a pod spec, but would manipulate the image field before essentially interacting with the version pod controller and converting that versioned image name, like what you specified here, into a concrete image version, and then pass that off to a pod to continue its pod lifecycle. Now, another way, and I think the way we might possibly want to explore in this session, is Kubernetes provides two kinds of hooks when objects are created and when pods are being built. Actually, this works for any API object, I believe. You have mutation controllers and you have validation controllers. So going to validation controllers first. Validation controllers are pretty much like what they sound. Essentially, you can provide a completely valid Kubernetes pod spec or deployment spec or any sort of spec, and you might want to validate it in some way. So for example, you may want to look at the state of your cluster and say, oh, we should only be running this many deployments with this particular label, or this particular deployment is valid but is missing this particular like annotation, for example, and you might want to like validate that and say and deny that resource from being created. So for example, if when you create a pod spec and you add something that is invalid using kubectl, essentially you will get like a denied error if you write something invalid. That's essentially the validation kicking in. The other thing that you can do is essentially like a mutation controller. So mutation controller, actually it'd be quite good if we pull up the documentation on this. So if you could pull up maybe the admission controllers for Kubernetes. That one is fine. So essentially, both mutation and validation controllers are types of admission controllers. And what a mutation controller allows us to do is essentially hook into an object that's being created as part of the creation lifecycle and apply patches, apply mutations. So similar to how you can do kubectl patch, you can do that at pod creation time dynamically. And the way that they've implemented that in this particular controller, in this particular admission controller, is allowing for like a webhook style system. So essentially, every time a pod or deployment or something, whatever object you want to watch for gets created, it will essentially call into a custom webhook that we can specify, and then we can then mutate the output and add anything we want or tweak anything we want before it goes on to the rest of the pod or deployment or replica set creation lifecycle.
Awesome. The good news is I also found my tweet. There we go. So this was my bold idea, November 13th. I was searching December, which was wrong. But we're going to try and make something like this work. So that was a really great explanation of validating webhooks and mutating webhooks. I think, there's a lot of flexibility, a lot of power just in those two methods of being able to extend Kubernetes without getting into the nitty gritty of actually writing a controller with a loop and reconciliation and ownership of CRDs and all of that stuff. Like, you just want to extend like we want to today. A primitive that already exists, like a pod, and we can do a cool couple of tweaks there. So is it fair to say that at a really naive level that these are just simple functions that take an HTTP request in and spit something back out?
That's exactly it. Yeah. Essentially, right now, I believe admission controllers only give you the object as JSON, and you will read the object as JSON. And you can use the Kubernetes core v1 to unmarshal all the JSON that's provided to you, and you quite literally write if you've used customize or anything similar, you essentially write a Kubernetes patch. So you'll have like an operation, you'll have a path, and you'll have a value, and essentially you specify a series of patches that you want to run. You can specify no patches. For example, you could just say the same thing that's come in is the same thing that's going out, for example. And yeah, essentially that webhook is essentially just ferrying some patches, which will then be applied as part of the mutations, and then it will go on to the rest of the lifecycle.
Okay, so is that our first step then? Is that we want to write some Go application that we can deploy to our cluster, register as a webhook, validating or mutating, and just take in a request and just pass it on? Like that's step one, right?
Yeah, exactly. It's pretty much exactly as you described. We're going to write a really simple Go application, a Go binary, and get that deployed. And it gets deployed in the cluster just like any other deployment would. So, we're going to create a Kubernetes deployment. You can run it with multiple replicas. It will have a service backing it. That's basically it.
Awesome. I love how you say we. I feel that you're just taking pity on me because, I'm going to be leaning on you an awful lot for today's session. So let's get started then. We have a VS Code live share set up. We both have the ability to pair program on this and type code. I'm assuming we're going to want to just initialize a really simple Go repository, pull in client Go that we'll probably need later, and then build a Docker image. I'm guessing.
Absolutely.
Feel free to just tell me I'm wrong. That's not the first step.
No. I think that sounds really, really reasonable. Essentially, we'll get it'll allow us to interact with all the different things that are involved talk a little bit about the prerequisites before we get into the really quite finicky stuff of getting the actual webhook installed into Kubernetes itself. Towards the end, hopefully. Let's get started with some code.
Well, we also have a question. Are you ready? Because I wonder if you've got opinions on this. So Moz has asked, what are the differences between a controller and an operator?
I see an operator as acting on top of a custom resource. So for example, I would write an operator if I want to interact with something outside of the Kubernetes ecosystem. So for example, if I wanted to tap in to a Cassandra cluster and cleanly shut it down, as part of, let's say that I got an event that's saying that, a pod is about to be terminated, and I wanted to cleanly shut it down and reconcile that with my Cassandra cluster, I would term that as an operator. Essentially, it's like extending the Kubernetes lifecycle to do things with, especially stateful infrastructure, for example. With a controller itself, it's more taking and interacting with your Kubernetes system itself. So essentially, it's taking something that you want done in Kubernetes and using Kubernetes as a way of making that happen. So, I would typically have a controller like interacting with, standard Kubernetes objects, deployments, replica sets, pods, secrets, config maps, essentially describing those primitives. A controller and operator under the hood are like very similar things. You're going to have like one loop. You're going to be checking for like mutations. You're going to have like a Kubernetes watcher at some point, maybe listening for events. So like, in implementation, they might look quite similar. But like, I think it's just a matter of terminology. And to be honest, it's personal preference. Like, depending on what you read, where you go, the terminologies are really mixed up.
Okay. First, I just want to point out that your ability to answer and explain stuff is phenomenal. So thank you very much. Secondly, I'm going to throw a statement out there. Would you say that all operators are controllers, but not all controllers are operators? Does that pass?
All operators are controllers, but not all controllers are operators. Yeah, I think I would agree with that. You see, the thing is, in an operator, there's no reason why an operator, again, taking, for example, the Cassandra example there, there's no reason why, the Cassandra operator can't interact with both the Kubernetes ecosystem and also Cassandra itself. Whereas if you're writing a controller, I would probably want to scope it to just the Kubernetes aspect itself and leave the actual like management of like third-party infrastructure to something like an operator. Yeah.
Awesome. All right, we'll tackle one more question. They're fair coming in today, and then we'll actually write some code. So Sashin has asked, is there any difference between writing controllers from scratch versus using tools like KubeBuilder, Operator Framework, etc.?
That's a really good question. So with the pre-generated code that you get, it comes with a lot of like niceties out of the box. It writes a lot of the boilerplate for you. It gets you started on a really nice layer. It gives you like all the dependencies you need. It gives you some boilerplate YAML that you can start applying to your cluster. Actually, later on when we're writing this mutating webhook, it's going to be really interesting to go through the Kubernetes phase because there's so many finicky things that you need to do in order to get these mutating webhooks running. All of these things are not extremely well documented. So the interesting enough, when you generate something using like the operator framework, that might be the best source of documentation for running a Kubernetes controller. Because essentially that is part of the Kubernetes project, and they expect others to not go it alone. Essentially, they expect everyone to be using that sort of framework.
All right. Would it be fair to say that you only need to use KubeBuilder, Operator SDK, all these other tools when you're registered? Like, I always think of them as being tools that simplify, creating the CRDs, applying them to the cluster, providing the ownership. Like when you're working at that level, it would make sense to use one of these tools. But for today's example, where we're doing, a webhook that mutates an existing spec, that you don't particularly need those tools.
Yeah, that's exactly it. And also, I think by doing it from scratch, it's a nice way to understand how all the pieces fit together. All the pieces you need, and also. I also want to demonstrate, hopefully, especially the code side, it doesn't need to be that complicated. If you, hopefully, we'll have to see how we get on. Hopefully a lot of the primitives look familiar to like anyone who's written Go before, and maybe not played around too much with the Kubernetes SDK side of things.
Okay, right. there's lots of context there, lots of knowledge. I hope everyone is enjoying the session. I think we just dive straight in now. We start getting some code together. If you're watching and you have more questions, please leave them in the chat. We will do our best to answer them as we go. All right, let's do this. I'm going to assume we just need to run a Go mod init here.
Yeah, that's right. We're going to need to pull in the Go SDK at some point. I've created a main.go. So yeah, we're going to start with a package main. Essentially, what we're going to have is we're going to have a HTTP server listening on TLS. So a mutating webhook or any sort of webhook that interacts with Kubernetes doesn't interact over a non-TLS connection. So we're going to have to do some certificate faff a little bit later on. But we are going to be listening on a TLS connection. Now, as I say that, I have realized that we will also need some keys at some point. So for now, I imagine we're going to hard bake some paths, and then we can inject those in as a Kubernetes secret later on when we're setting up the Kubernetes side of things.
Yes, definitely. Okay, so Moz has given us some moral support here. Let's do it. Thank you. Now, this is we're just going to use net HTTP right from the Go standard library. So, I mean, I'm not going to remember how to type that off the top of my head. I'm going to assume you probably may be able to type that off the top of your head, but we're just going to grab that from Google, right?
No? Yeah, I'm going to go for the typing.
You're going to go for it, right?
Yeah, I'm going to go for it. Let's see how much I can remember. So, essentially, we're going to need http.handle func, I believe. And essentially what that's going to look at is we're going to have a mutate endpoint and that's going to call into a handle mutate function.
Is that mutate endpoint convention or explicit?
You can specify it in your YAML, but it is convention. It is just what all the mutating webhooks seem to be using. So this is going to be a response writer, and we're going to have a HTTP request here. Hopefully I got the order of that right. Value of type func. Oh, sorry. I think I just want the handle. There. And we're going to have a HTTP listen and serve TLS, and we can have it listen on port 443 and assert server. Oh, sorry, webhook.assert and have asserts. Webhook key.pem at some point. So we're going to have to inject those in as a Kubernetes secret. I wonder why this is not liking. I believe we do need a handle func. Correct.
Was it not? Hold on. If I get the autocomplete up, I'll just show people. It did say pattern and handler was accepted here. So let's see. What's the error message?
I think I've gotten the pointers the wrong way around.
Cannot use handle mutate value of func blah 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 as HTTP handler value and argument HTTP handler missing if it's serve HTTP.
I had the pointers of the arguments the wrong way around. The HTTP response writer is it's just a standard struct, and the HTTP request is a pointer. Serves me right for not Googling. Cool. Now, what we get in, if maybe we quickly pull up the documentation for an admission controller. So if you maybe search for admission review, maybe it's on this page.
Nope.
No.
That's the admission review. We just want that struct, right? So.
Yeah, that's right. There we are. Actually, that's perfect. So webhooks are sent a post request with content type application JSON, and it has an admission review API object in the admission.ks.io API group. So essentially, that's what we're going to be like getting in, and as a response, we'll also be sending back out, and it says later on in the page, an admission review response. So admission review has oddly in like non-Go standardness, it has like an admission review and then a request inside it, and it also has the response inside it as well. So we'll get an admission review and we'll send back an admission review. So let's write a really, really simple one where we're just taking in the admission review and marshalling it, and then just spitting the same admission review back out. And in order to do this, we're going to need the Go API, sorry, the K8 API. So if we do go get.u K8.io API, that will download the latest API and also put it in our Go mod, and that should be ready for use now. So if we have input as admission v1, admission review. This is the struct we're going to drop into. Let's see if the PLS will like this. Admission v1 is case.io/API admission v1, which is where the actual like admission lies. I think that's just resolving on my end. So while it's resolving, I will continue coding. So essentially what we want to do is we want to decode the body that we get from the request into this admission review. So that's going to be auto body and decode review. For all my girlfriends that are watching, we're going to be quite liberal with the errors that come out of this. We're just going to send them back out. Interestingly, what you can do is within the when you're writing an admission controller, if it does return an error, you can specify as part of your mutating webhook whether you want the admission to fail because it couldn't resolve, or to ignore. So essentially to just continue on with no mutations being applied from the mutating webhook. So when we initially set it up, we're probably going to set it to ignore level because we're testing around. But then we may switch that to a more stricter policy of failing if it encounters any errors. So I'm just going to define maybe a send error function, which is going to take an error. And what that's going to do is that's also going to take our response writer as well. Writer. Is we want to send back content type application JSON. And we also want to send back a status code. I think the autocomplete has sort of broken. Internal server error. That's all right. I'll just continue to type while it catches up. And we also want to marshal the error at some point. So if we have marshal match string
I think the compiler caught up, so hopefully you have your autocomplete back.
Oh,
although it keeps saying error loading workspace. Updates to Go sum needed disabled by mod read only. Alright, okay. Go mod's just a bit unhappy. We'll try and fix it when you're ready.
Cool. So what I've done here is I have output that error, and there's not much we can do if we're already in the process of sending an error and we have an error whilst we're trying to encode the error. So hopefully that will succeed all the time. And we want to write that out, and we are done there. Let's see. I probably needed to download all the dependencies.
Yeah, hopefully that keeps it happy. Undefined JSON.
Undefined JSON, yeah, so we probably didn't import that. Thank you. And I think we're missing our listen and serve TLS.
String handler.
We need to specify a handler. Or I think I might need to wrap this in a serve mux. We need a server, HTTP server, free, and handler is going to be max, and then serve, listen and serve TLS. We don't need to specify the port because that's in the address. See if that. I've got a saving main.go here. I imagine that's not saved yet. Over.
Getting code actions from Go. Thanks, VS Code. Very helpful. Yeah, I'm not sure what its delay is.
Oh, okay. I think that just saved. So
yeah, it says we have string, and I want string handler.
Yeah, but we don't have http.listen and serve TLS anymore.
Ah.
So I wonder if it's even reading that code. Let's have a look. Main.go. Yeah, so it's still got our old code there. I don't think VS Code has saved that.
Let's see, what is this saying? Cancel. Let's try. Maybe it's just unhappy because it's trying to run something. So let's make sure we have our dependencies. Save. There we go. Okay, so we got package JSON.
Okay, that's good. Does it need to be encoding JSON?
Oh, yeah, I think you're right.
Am I on that line? If you just add encoding /JSON, there we are. Sweet.
Oh.
Let's give that a build.
Okay, we're closer.
We're getting there. Not enough arguments in call for HTTP error. That's line number 22. Ah, cool. Okay, so that's just on our error line here. So essentially, what we want there is we also need to specify the return code. Status internal sub error. Yeah, that should work. What else was it compiling about?
Handle mutate has got a few bugs, yeah.
Yes. Okay, cool. So that should not be review, that should be input. And if does not equal nil, send response writer.
To the people watching, we'll go over all this in a moment once we get it compiling.
Yes. Could not on Marshall review.
Ricky says, I can't believe there's someone who can code without IDE autocomplete. Yeah, it's not me. I'm glad it's Suhail, that's for sure. And I would have copy and pasted all of that HTTP handle stuff. You were very brave there. Or silly, who knows? We'll find out.
Yeah, I think it's probably the latter there. Brave, I think I think is giving me too much credit.
You did well. You were pulling it out the top of your head, and it's even compiling now. So
oh wow, amazing!
All right,
That
so
is sheer luck.
let's just take 1 minute to go through this, talk about what's actually happening. I know it's mostly boilerplate. I think that's should be encouraging for people who've not actually done anything yet. This is literally code you could, if it works, copy and paste and use it for all of your admission controllers. So I'll let you just take a wee bit of time to run through this since it's your code.
Yeah, absolutely. So starting at the bottom there into our main function, that's going to be our entry point. And essentially what we're saying there is we've defined one endpoint, the mutate endpoint, and that's going to call into the handle mutate function there. We're listening on port 443. That will listen on localhost. So we need to set up the container port forwarding in our Kubernetes. In our Kubernetes manifest. And essentially, we are setting up a TLS server. So what Go will do under the hood is it will set up a TLS wrapped HTTP server. So it will do all the TLS validation for us. Everything that is necessary. We probably wrap this in a log.fatal just if it quits for whatever reason, and this will essentially block, so it will continue listening forever. And I've just wrapped it in a log.fatal to print out any errors if it exits uncleanly. Yeah, so that's our main function there. If we scroll up a little, we've defined a mutate handler, HTTP handler, that takes in the two traditional arguments for every HTTP handler, which is a writer and the request. Oddly, the request doesn't come first as an argument. If I was the implementer of this, I'd put the request first, just because that's how I think about it, request then response. But here you get it the other way around. So yeah, you have just a standard HTTP Go boilerplate function, which is taken in our request. The actual payload itself is in the body. So we have r.body. And essentially, we need to write out any sort of response to the response writer. Now, the response writer is quite literally an I/O buffer under the hood. So, if you were using Netcat or something like that, you would have to send out your response in the same order. So you need to write the status code. You need to write any headers that you need to write first, and then you write out your payload in the end.
All right. Now, I guess I have a question. In our handle mutate function, we're not returning anything.
Yeah, that's right. So the handler has no mutation arguments. So it has no return arguments. It doesn't return anything like an error or anything like that. Think about it from a Go perspective. If a Go is serving a HTTP request within the boundaries of that particular function, anything that could error, it would have to be a panic level error, where the entire program just crashes. Otherwise, all the other errors are meant to be handled in the request response lifecycle. So, for example, if you encounter any sort of logical error with the request that comes in, we've written a boilerplate function to send out an error, because we'll be using this quite often throughout the handling of the mutation itself, as well. Especially when we're encoding things back and forth, there's always places where things could fail, and in Go it's good practice to always handle the errors as soon as they come in, and not ignore them, unlike Java, where you just have a big try catch block.
Okay, could we just explain okay, so if there's multiple admission controllers registered with our Kubernetes API server, and we're one of many, how do those interact with each other? How are they modifying the request? Is there ordering? Is there priorities? How does that work?
That's a really good question. The ordering of admission controllers is well defined, for within Kubernetes itself. I'm not quite sure how ordering works if you have multiple mutation controllers, and if there is any preferred ordering there. So I may need to look that one up. I'm not sure actually.
If I'm going to keep throwing hard questions at you. We could look this stuff up. It's all right. I think that's pretty normal. If I mutate the object, does it rerun all of the others because the state has changed, or does it continue from where that happened? Do you know that?
I believe it continues from where it left off in the life cycle. So it'll just continue going as like one big pipeline, like end to end.
Like a middleware layer of some kind.
Yeah, exactly. Yeah, like a middleware layer of some kind. Yeah. So essentially, you would want to like order these so that you have your the thing that you want. If you require any specific ordering, and if ordering is possible, that you have ordering in the sense that if something in the last in the order relies on something from the first, then you specify it in that way.
All right. Well, I think the intricacies of that will come out as we actually apply it to our cluster. So we do have a Go binary right now, which I expect to fail because of those certs.
That's right.
Okay, well, it did nothing. All right, we'll fix that in a minute. Now we want to provision certificates, build an image, and deploy it to Kubernetes.
Yeah, that's right. So what we want to do is essentially give Kubernetes everything it needs to get this up and running. So why don't we create a folder with some manifests, and then we can start creating an image and getting that applied. Actually, we should probably first create an image, a Docker image. So I imagine we're probably going to want a Docker file.
So we set our working directory, we copy everything to it, we run a go build. That should give us a binary, and I'm not going to worry about adding like a smaller image and stuff like that. We're happy just to deploy this one as is.
Yeah, absolutely.
So Kubernetes semantic version. Terrible name, but we'll go with it.
Yeah, let's go with it.
So we should be able to do an image build. Let's call this Rawkode Kubernetes semantic. I'm just going to take all the credit and it's now my image thing.
Absolutely.
We built this, and what did I get wrong? Oh, did I get the Go image wrong?
That seemed like an auth error.
It's Golang,
Is it Golang? Yeah.
And we'll just do Alpine. Keep it as small as we can. There we go. That build should be pretty quick. Pulling down our objects. All right, let's tackle a question while that builds. Okay, mods gave us a comment and then a question. So why is autocompleting not working? Have I got it disabled? And what VS Code theme am I using? Autocomplete was not working because it was downloading dependencies in the background, and then it was failing to run some sort of compile step or something. It seems to be working now, so hopefully we're okay. I think this is the plastic theme. People always ask for themes. People love that. Panda syntax. There we go. This is Panda syntax. And then Moz had a question: does the certificate, or should the certificate signed by the Kubernetes CA or self-sign work fine?
Yeah, so we're going to have to issue a certificate that's signed by the Kubernetes CA. You can provide a CA bundle, but that will also need to be that will be validated by Kubernetes itself. So to avoid a little bit of faff, we can. I think it's best if we use the Kubernetes CA because that's already going to be automatically trusted by Kubernetes itself.
All right, so question time then for me this time. We're going to write a Kubernetes manifest to deploy this. Is the standard way for admission controllers to have a deployment with replicas 1? Do people use a straight up pod or stateful sets? Like, what is the de facto here?
Yeah, so we'll create a deployment, and you can have as many replicas as you want. So we could start with replicas 1, but imagine if you want this to work on a highly available manner, especially if it's stateless and idempotent, then essentially if one request fails, for example, because the pod had died, the mutation hook itself, then it would just reroute to another pod. So yeah, just a standard Kubernetes deployment, and we'll also have a Kubernetes service as well, which is going to be fronting our webhook. And then gets the interesting bit, because we're going to write a mutating webhook configuration.
All right, does that look okay?
Yeah, I think so. Yeah.
All right, let's see if we can apply our opt Kubernetes directory. Dun, dun, dun.
Lovely.
What did I build it wrong? Yeah, I spelled it differently. No. Kubernetes context. Ha. There we go. Let's reapply.
Oh.
Now, container. Okay, so we have an error, but we did deploy successfully. And I think that's just because when we run our binary, nothing happens. And if we pull the logs, it's just unable to open our certificates. So
yeah,
we're good.
I'm not quite sure why it's not running properly on your machine. I don't know if it's actually erroring out, but that's the line there is what I expect. Maybe.
Yeah, it runs successfully locally.
Interesting. Could you try running it again? I've just done a go build on the local machine.
Oh,
there we are. That's it. I don't think we had the latest binary built on the local side. Classic. Cool. So we're going to have to inject in these certs. And in order to generate them from the first place, we're going to use a tool called CFSSL. So this is a set of tools that Cloudflare have provided, where it allows you to specify a certificate configuration in JSON format, and it sidesteps the need for OpenSSL. I can never ever remember the syntax for OpenSSL. I always have to Google it. It's really obscure. Whereas with CFSSL, at least you can reason about what you've generated. So let's go and create that. So we're going to generate a certificate signing request. So maybe if I create a new directory in here. Do you have CFSSL installed and also CFSSL JSON?
Well, I just installed CFSSL. Do I need to install another package?
Yeah, you'll also need CFSSL JSON, no dash, I think. Does it come by default, maybe?
I'm not sure. Let's find out. So we want to generate a CSR.
So if we do CFSSL JSON, and what we're going to do is we're going to specify the CSR in JSON as in CFSSL JSON as in one command.
One command.
Yeah. It probably might come by default.
Oh, it does. There we go. I don't know because I've not reloaded my shell, so I'm not getting autocomplete on the commands, but it is there. Okay.
Cool. So if we go back to the editor, I'll show you what the CSR looks like. So essentially, and I am copying and pasting a little here. Essentially, what we're going to do.
What should I be looking at here? Sorry.
I've created a new directory called CSR, and in there's a file called csr.json. So what we have here is the declaration of the CSR that we're going to create. So what did we call the Kubernetes service? Was it semantic?
Semantic, yeah.
Yeah. Okay. Cool. Semantic. And essentially, we are allow listing the those particular hosts as part of the certificate signing request. That's going to be the common name. And yeah, I think we have everything we need to start generating the actual certs themselves. So what we're going to do now is if we do SSL JSON, I'm just make sure. So if you cat your csr.json, yep, and then pipe that into, is that saved properly?
Hopefully I've just saved it, yeah.
There we are. Yeah, if you pipe that into CFSSL gen key, because we're going to have to generate a key first, and you also need to specify a dash, and then we're going to pipe that into CFSSL JSON dash bear, BARE, bear, and we're going to generate a server key. So if you, what did we call the? You're going to need one more argument, which is the name of the output file. And what did we call it? We called it webhook. So if you call that webhook, that's it, just webhook. It will generate the required prefixes because it's going to generate two files. Cool. So that's now generated two files, hopefully.
I did. Webhook CSR webhook key.pem.
Yeah, great. So what we're going to do is we're going to take the certificate signing request, the CSR, and we're going to base64 encode that, and we're going to create a certificate signing request for Kubernetes.
Okay, so we want the CSR.
Yep.
Base64. So
that's right. And if we need to create one more manifest, which is the certificate signing request for Kubernetes itself.
Yeah, I don't think I'm going to have a magic template for that. So let's put that here, and then let's go find Kubernetes CSR YAML. Let's see if we've got one here. Some RBAC stuff. And there we go. So we want this base64 encoded version.
As part of the request.
Do we need to modify anything else within this?
Yes, we're going to modify the metadata to be the name of our program, so semantic. So the name is going to be semantic. We also want the signer to be the kubelet itself, the serving kubelet. So that's going to be Kubernetes IO /kubelet-serving. Yeah, and essentially we want the mutating webhook to be authenticated with the system itself because it's going to be interacting with Kubernetes within the Kubernetes certificate framework. Yeah, I think that looks good. So if we apply that.
So we run get CSRs.
That's right. Yeah. So you have a CSR that is pending, and what we'll need to do is we can within kubectl approve it. So if you do kubectl certificate approve, I believe.
Certificate approve.
And then the name of our certificate. Yeah. Amazing. Cool. Now we'll need to extract out the.
It says failed.
The certificate. Oh, could you describe that?
Not particularly useful as far as debugging events go.
No. Interesting. Yeah, there's nothing there. In the certificate does look valid to me. Oh, I wonder if we need to add a few more usages, because I noticed that there's only one usage there, which is client auth. I think we need key cipher and digital signature as well.
Okay, so just delete the CSR and then we'll throw it back.
Yeah, if you delete the original CSR. Let me see if I can add the other two quick. Just make sure that's correct. So what I've done is I've added the last two lines there into the usages, which is digital signature and key encipherment. Now let's give that a shot.
Failed.
Let's see, what else do we have here? Your request does look valid. Let me just base 64 decode this.
I bet it's a new line or something.
Oh, the certificate request looks valid to me.
Yep, that's good.
Interesting. I knew this was going to be a faff. Certificate.
I wonder if it's a Docker for Mac thing. Maybe I shouldn't have skipped over this RBAC stuff. Oh no, because I'm just root on this, so it doesn't really matter. Okay, Docker for Mac CSR failed. Let's see what Google tells me.
I think you do need to remove the new line. It might be a little bit picky. I'm just looking at the Kubernetes documentation. So when you base 64 encode it, if you could pipe that into tr-d and remove the new line.
Okay, so we want to cat the webhook CSR, but we want to tr-d and then base encode.
I think we want to base. So according to this, it base encodes first, and then. Oh, actually, then it's just removing the new line.
Yeah, from the base 64.
Okay, maybe it's not that then.
I mean, let's see. What does that do?
Well, you also need to specify delimiter. So you want to specify in quotation marks -n. Yeah.
Oh no, we don't want that.
Yeah. That's just remove the new line.
Oh, there's a cool tip from Noel. Base 64 -w. I'll look at that in a moment. I think because I catted the CSR and base encoded, I actually think it should be all right. And normally, if there was a new line character and on the end, you would see this really familiar. Like you would see the two equals with the padding and something. So.
Could you possibly specify in the metadata, this is a long shot, in the metadata, specify a namespace? So if you do semantic, and what namespace are you in default? I think you need to specify that in the name. So if it will just be semantic.default. This is really much a long shot. Let's give this a shot.
We like long shots. All right, let's delete CSR semantic because you're failed. Let's reapply alt Kubernetes. Let's get our CSR. We can see it's pending. Yep. Certificate approve semantic. Dot default, yeah. And get CSR.
Oh no.
Right, let's see. What have we got in our kube system? I mean, there must be logs on this, right?
Yep, likely.
So if we get the logs on the API server, I'm not sure what would be responsible for this here. I don't think there's anything useful there. Let's try controller manager. Nothing useful here either.
Let me give this a shot on a local Minikube plus mutate hook.
Okay, let's try Kubernetes admission controllers or CSR. I'll just Google random stuff just now. Let's see what happens. Oh, I think the signer is wrong. Is it kubeAPI server client kubelet? Or no, you said serving something, right?
Yeah, kubelet dash serving.
Yeah, that does look okay.
Do we have system modes? Organizations are exactly system modes. Common name starts with system node. Did we get that correct? So our common name is, let's just make sure that our CSR is correct. Semantic.default.service, semantic.default.service.cluster.local. That's fine. System node.
I wonder if that's different on Docker for Mac.
Ooh, possibly.
Ricky suggests we just restart my computer. Maybe not today. Yeah, I wonder if the Docker for Mac cluster DNS is different. Let's jump into. I bet you this doesn't work because of it's a funny distro list or something. Let's try. Yeah, it's not going to work. How can I get the full thing? Let's go. Let's run something. I'm just going to get a debug container in here somewhere. So
yeah, like a busy box or something.
Yeah, something I can do a DNS lookup. I'm not sure if there's a quick way to get the actual cluster DNS name. So from Docker for Mac at least. Let's just run Ubuntu 20. Just whatever Ubuntu gives me by default. And then my old favorite sleep, args, infinity. All right. Get pods. Should maybe have picked a smaller container image. There we go. It's running. So let's get inside of this and run bash curl wget dig. All right. Install bind tools. I can never remember the name of the bind package. Bind tools, DNS utils, DNS tools is one of them though. Yeah. Well, I guess I can just do curl. It's not really that important. So so we want to confirm.
So what's your current theory at the moment?
That Kubernetes.default.cluster.local won't work. Default.svc.cluster.local. If that was DNS, it would probably fail for another reason, right? No. DNS tools. Utils. Bind utils.
Ooh.
Oh, close.
Bind 9, yep.
Okay.
There we
So
are.
now
Getting
I should be
somewhere.
able I wish that package name was just consistent across every distro, but I seem to fight with it every single time. Ugh. 8. 27. That's annoying, but all right. Dig Kubernetes .default.svc. Really? Ubuntu dig command package. I wish I could say that's the first time I've googled that. Bind utils. Did I not try bind utils? Or did I try everything but it? And I did install that. Do I have NSLOOKUP? Dig. I can't believe this is what I'm now failing on. DNS utils.
DNS utils.
Sabin has asked if I'm on an M1. I'm not on an M1. Unfortunately not. Yeah, so that's, I think Sabin's confirming my hypothesis, is that the cluster DNS is actually different. They're suggesting docker.internal. So, I just want to confirm that. So Kubernetes default svc dot cluster dot local. Now that does the resolve actually.
Interesting.
Could
we have a quick look at the could you describe the CSR again? Semantic dot default, right? The CSR name should be semantic dot default.
Yeah, but that system node at the start, what is that? Because that doesn't look like a valid common name to me. Is that wrong?
So according to the documentation, that is what it should be. The common name should start with system:\node. And then it should have a colon with the name of your full common name.
Okay, so common name starts with system:\node:.
Yep. So the organization needs to be exactly system nodes, which we have. Yeah.
I wish there was...
The certificate signing request looks correct to me as well.
Yeah, so the kube controller manager does handle this. Let's try the logs again. Logs, kube controller manager. There's nothing there.
So what I've done is I've generated a new certificate signing request, like an absolute long shot.
Well, that's the advice we got from Moz. He says regenerate the CSR. So let's
yeah, exactly. Now that's going to generate a new base 64 encoding. And what we're going to do there is let's remove the original object from Kubernetes and recreate it.
Okay, so delete CSR semantic. It's gone.
Yep, and okay. Default. No, that one failed with an error. Yep. Can we just check to make sure it's still not there? Perfect.
Yep, all good. So now we want to cat our CSR.
Yeah, I've called it. I've called it. No, I've already done that. So I've called it server.csr this time. Previously we called it webhook, but I called it server. So yeah, if you copy the base 64.
What was that thing we got? -w0.
No, I think that command should be correct with the tr. That will remove the new line, and then we can, if you pipe that into pb copy, that will copy it onto your clipboard.
Yeah, okay.
That's it. And if we go to search.yaml and put that into the request.
Okay.
Has that been put in?
Yeah, I don't think it changed, which means that it's probably the same.
No, I don't think it should be. It would have generated with a new key and a new algorithm.
Right. Well, it's maybe just something in the middle that's changed, and the end is consistent. So let's try applying it.
So what I've done is I've just taken the output from the terminal and copied and pasted it myself, and it definitely changed.
Weird.
Interesting. Let's try and apply it though. I hope it will work.
Oh.
Oh. Plan block type must be certificate request. You're wrong. That's just come out there. Into base 64. Yeah, that's a certificate signing request. That is a PEM request. Correct. Opt Kubernetes.
Yep.
The certificate spec request has invalid value. That's really bizarre. Maybe you're right. Maybe it didn't change.
Yeah, that seems better.
Cool. That's now created it. I'm wondering whether we truncating the new line didn't work properly as I'd expected. Now let's try and approve it.
All
That's
right,
a long shot.
Approved. Ugh.
Oh no. Okay, I don't know if this is a Docker for desktop thing.
Let's change clusters, right? I have other clusters available. So,
do you have a Minikube cluster?
Yeah, we can create one pretty quick. I also have a fully fledged 9-node cluster on Equinix Metal that we can always resort to if needed.
Oh, that'd be great.
Maybe slightly overkill for building the MutatingWebhook, but would be fun regardless. Let's see what Minikube gives us then. We'll just apply this entire certificate thing right over the top, approve it, and I bet you magically it's just going to work. And this is some weird Docker for Mac thing.
Yeah,
I can't think what else it is. Yeah. What we have looks like what's in the Kubernetes documentation. So let's see.
Exactly.
Okay, come on, Minikube.
While you're getting that up and running, I'm going to try and see if I can get.
All right, so if I run get nodes, I just want to make sure we're on Minikube. We are. Let's apply. I should be able to run get CSR. Oh,
are you running the latest Kubernetes on Minikube?
It was running 1.18.4. Do we need 120?
I think we'll need 120, yeah.
All right, let's tear that down. Start Kubernetes version. All right, I'll just take another moment. The image isn't too big, so.
What version were you using on your Docker? Was it 120 as well?
It was, yeah.
So according to this random post I found on the Docker forum, always to be trusted, right? It seems it wants the signer to be suffixed with docker-desktop.
So it is a weird Docker for Mac thing then.
Yeah, possibly.
All right, well, the only thing that changes now anyway is we just have to rebuild the image using the Minikube context. Other than that, we should hopefully, once this spins up, we're back on track. Fingers crossed.
Cool.
Almost followed by certificates. It's just the way it goes.
I did mention at the beginning that it would be a bit of a faff. So once we have these certificates, essentially, we'll have everything in place for Kubernetes to interact with this webhook and ready to intercept some requests.
Yeah, we've not even done the hard bit yet. We've got to parse and resolve that random semantic version thing I've thrown at us. It won't be that hard, I'm sure.
So there's a really great Go package that I came across a couple of weeks back called Semver, which is really quite nice because you can specify a semantic version and specify, grab a list of other semantic versions and see if they match and also sort them. So essentially you can say, oh, if you have like more than like 1.15, it'll and then comma less than 1.16, it'll accept everything within that range, but not 1.16 itself. So everything above 1.15, but not 1.16 itself.
So it does all the hard work of the stuff that we actually need to do.
Exactly, yeah. It does all the hard work for us. Yeah.
Oh, it failed.
Did that one fail as well?
Yeah, I'm going to describe this other one that we have in the Minikube cluster though. What's different here?
The sign is different. Kube API server client Kubler. That's the only thing I can see that's different. Semantic.default.
Well, we added the .default. I guess we could always remove that, right?
I think I know what the problem is. In the usages, the documentation says you need server auth, and we've got client auth. So let's remove client auth and change that to server auth. I would hate for this to be the issue.
All right, let's delete. Well, these things are here to teach us things. So let's approve.
Yay! Oh dear. Oh no.
Oh well.
Oh no. Okay, cool. Right, we're back on track. Do you want to give that a very quick shot with the Docker version, as well?
Yes.
Or would that be too much faff?
No, it's all right. Let's just pull it back to Docker desktop. Reapply.
Because then we'll be able to avoid the having to build the image into Minikube itself.
Approved. Oh well, that's an old one. So let me just.
Yeah, that's the old one, I think.
Apply. Approve. Oh. Oops. Approve. Go back the right amount of commands. Issued.
Yay!
Perfect.
Cool. Amazing. Cool. So from there, what we need to do is we need to extract out the certificate itself, the certificate authority data. So we've approved the certificate, and now we need to extract the CA from Kubernetes itself to put into our bundle. So what I'm going to do is I'm going to put the command just in the file that you're looking at, for you to copy.
Or you can just type it into the terminal if you want.
Oh yes, actually, yeah, that would be good. So very weird wraparound thing.
That final pipe should be there, right?
Yeah, that final pipe shouldn't be there. it did a weird wraparound thing for me, but there we are. Okay, cool. So this is the certificate authority that's for your Kubernetes cluster. And what we're going to do is we're going to reference that as our CA bundle. So this gives us the last thing that we need. Our Kubernetes cluster now trusts that that certificate. We've done all of that. This is the last bit that we need on our side. So
am I just copying this and then creating a secret of it?
So yeah, what you're doing is you're grabbing that and you're base 64 decoding that as well. So we need to base 64 decode that.
So why do we need this? Because this is already in the cluster, right?
Yeah, so this is the certificate authority that has like signed the request. So we're gonna have to put this into where do we need to put this? We need to put this into the webhook itself. So we need to specify the certificate authority bundle that has trusted our webhook certificate. So imagine it like this, right? Imagine that we didn't use the Kubernetes CA to issue the certificate for our webhook. We need to tell Kubernetes, where do you go look up the authority for that certificate itself, right? So you can specify that as part of your configuration. So one other piece that we need to create is a mutating webhook configuration, right? Which is, here Kubernetes, go and inject this webhook into my cluster and be ready to start calling it. So maybe why don't we create that first, and then hopefully this will make sense why this is necessary.
Okay, so let's create admission.yaml.
That's right. And what it is it's going to require a little bit of boilerplate. But if you look for mutating webhook configuration,
let's see if we've got one here. So kind, nope.
if not, then I can get us started with the boilerplate that I have on my end. If that's easier.
That's weird. Yeah, if you've got it there, we can just do that. I don't know why my GitHub search didn't work there.
Cool. So we've got an admission.yaml. So essentially what we're doing is we're starting with the mutating webhook configuration. We need to give it a name, just like all Kubernetes resources. So we're going to call this semantic, just to keep things consistent. We don't need a label, I don't think. And yeah, from there, the webhook itself. Now, this is going to be the name of the service that needs to be called. So for us, that's going to be semantic.default.service.cluster.local. Does that look right to you?
That is right, yep.
Cool. We're also going to need some rules. So essentially, we need to tell Kubernetes when should this webhook be called. Like, what kind of operations are we watching for? What kind of resources are we watching for? What API versions? So here I have just pasted a set of rules for, we're watching for the creation of pods. And the good thing about this is that it's not going to look for just manual creation as well. Like, if another controller is creating pods, it will also like pass through appropriately. We also, I mentioned earlier that we want to specify like a failure policy. So what happens if the mutating webhook fails? Like, for example, the webhook doesn't exist or like whatever. Now, the default policy is to fail, which means that our cluster will essentially error out and say that we couldn't call the webhook. I've now failed the creation of the pod. We probably don't want that from the get-go, so we're going to start with ignore. So what this will mean is that it will try and call our webhook as like a best effort thing. If an error is returned or a failure happens during the call, it will just ignore that and move on. Now, the other thing that we need lastly is a client configuration. So this is the configuration for how our webhook should be called. I mentioned that we need to provide the endpoint and the port. So we need to provide the service itself. We need to provide the path and the port. So essentially, because we've specified a mutate endpoint, we're gonna pass in that mutate endpoint there and port 443. And we also need to provide the name of the service as well. So the name is going to be semantic. Now, I mentioned earlier that we're going to need the certificate authority itself. That's also part of the client config. So, when you copy the certificate authority data of your cluster, that's where it goes, the base 64 encoded version. And that essentially lets it know what certificate chain it should be looking for. And because we're using the certificate authority of Kubernetes, CA, we need to paste in that chain here to let it know that that's the certificate authority it should be using.
All right, got it.
To validate our cert. So do you have that copied? Could you paste that in there?
I'm going to copy it again just in case. But oh yeah, I didn't run the command. There we go. So that should be it there.
Cool. What was I complaining about there? Missing property namespace. Oh, I wonder if we need to specify namespace there as well. Cool.
It says it's missing required entry side effects.
Side effects, yeah. So when you're creating a mutating webhook, essentially you can specify whether your webhook is going to create any sort of side effects. So is it going to interact with anything that's not been passed in? Now, for us, because we're taking in the actual pod that's being created and just mutating that as part of our patch, our program has no side effects. So we're going to say side effects none. Now, admission review versions. This is quite an interesting field. So right now, what we have is we have resources that are specified, like, as part of our API versions, like V1 pods. Now, when Kubernetes came out, a lot of these resources, deployments and replica sets, were in Alpha 1, Beta 1, Beta V1. What admission review versions does is that it will cast older and newer versions into the version that you are requesting. Now, because pods is currently V1 and we want it to remain V1, essentially we're going to say admission review versions just V1. Does that make sense?
Yeah, I think so. Can I just check with you? Are you okay to keep going? Because I know that our session was supposed to end around now. So if you're available, we can keep going. If not, we can always schedule a part 2. What works for you?
I'm totally fine to keep going,
Yeah,
as long as you're okay with it.
Yep, perfect.
Cool. It'd be nice to get this mutating webhook up and running, and then we could possibly leave the semantic bit for part 2, or whatever works. Cool. So that is all we need for this particular resource. So let's try and apply that.
All right. So I'll just do admission. That is now created.
Cool. Now, if you fetch that resource.
Mutating. And describe it.
Yeah, if you describe it. I don't think it's going to be very informative.
There we go.
Cool. So essentially that's now created our webhook, and our service will now be called each time. Now, I think the last thing we need to do is just to set up our secret so that we're injecting in the certificates for our pod, and then we should be good to go. Then the whole life cycle should be up and running.
Okay, so what we want to do is add a volume.
Yeah.
There's, oh no, don't autocomplete that. We want a secret. Let's see if I can get. Nope, that's not it. Is it? What am I doing? Defining a volume, right? Okay, there.
Yeah, you're defining a volume, and that volume will probably be injected from a Kubernetes secret.
Yeah. I don't know why. Oh, That's not what it offered me a second ago. There we go. And the secret name. So
we'll just call it as semantic because we haven't created a secret
we
yet.
haven't created it. Okay.
Yeah.
Semantic. And we're just going to take everything, and then we want to add a. Well, this is my debug one as well. Let's copy that.
Oh, yeah. I think you're in the debug manifest.
And then we want to add volume mounts where we mount our semantic, certs.
Certs, yep. And we want to put that in /certs in the root directory.
Done.
Sweet. And we also need to create the secret itself. Cool. Yep.
No, I call it semantic. And now we need our certificate.
Yeah, so we're going to have two things here. We're going to have the key itself, and we're also going to have the what else do we need?
Cert.
We need the cert itself. Yeah, we need to extract the cert from Kubernetes. How do we do that? I did have the that command saved as well. Yes, we need to grab the cert from the CSR. So let's get the key in first. So the key is going to be webhook dot. What do we call the binary? In the binary, we called it webhook -key dot pem.
So what am I doing? Sorry.
So what you're doing in the data is where it says key. You're probably going to want to rename that to webhook -key dot pem.
Yep. Got it.
Yep. And then that's going to be a base 64 of the server -key dot pem in your root directory.
All right, next.
Cool. And we also need to grab the certificate from Kubernetes itself. So we submitted a certificate signing request, and we now need to go and fetch the certificate itself. So if you do kubectl get CSR and then semantic.default, you will need to. Yeah, actually, I wonder if it does come in. Yeah, there we are, certificate. So if you just copy all of that. That will be our certificate itself. Amazing.
You would think that Kubernetes would provide a slightly easier way to access a certificate signed with its own CA system, just to, instead of extracting them out, creating a secret where I could just say, hey, pass this through to this thing. But I'll rant about. Maybe we can rant about that later. Okay, so we now have a secret. These names have to match what we have in our main.go, which were webhook.crt, webhook-key.pem, and we have webhook-key.pem and webhook.crt.
Amazing.
Which means, if I don't mess it up and do an apply of everything this time, I guess we can just do the deployment. That should create our secret, update our deployment with the volume mounts, and we should see our new pod scheduled. And it is running.
Oh, amazing. One thing we didn't do is we didn't add any sort of like debug line, so we're not going to know if our mutation function gets called. So let's do that very quickly.
Yep, agreed.
So very, very
fancy.
But yeah.
Where's my
I'm a serial print line debugger. I very rarely step into like GDB or like any sort of like Go delve or anything like that. It's done me well so far.
Yeah, I resort to print debugging, and then I'll cave and jump to a debugger if I feel that I'm wasting too much time. Like when I start doing I am here 76, I'm like, okay, maybe I should get a little bit more sophisticated now. And I lie, I never do I am here 76. I put swear words, and it's
Oh yes, yeah, I am his favorite debugger for sure.
All right, so we built that image. All we need to do is delete our pod. And what we should see now is if we run logs and create a new pod, that is called, right?
That's right. So if we maybe just kubectl create pod with like nginx or something, we should expect for it to be called.
Yeah, I'll just pop in here. I'm just going to make a chain. In fact, no, because this works on a pod and not a deployment level, right? I should be able to just delete the debug pod, which will get recreated.
Yes, if it was tied to a deployment. Ah, lovely, amazing. It all works. That means all of our certificates are correct as well, which is great. I don't think we need any more certificate debugging for the rest of the stream. All right, cool. This means that the whole like end-to-end chain works. I think how far do you want to go? We could get all of this up and running, and now it's just pure writing code.
Well, why don't we, if you're happy to work till on the hour, that gives us around 20 minutes to hack together something with the semantic version. And, I don't think we need to show it complete end to end. We can, we just want to now show how we iterate on this. We work with the client Go. We'll do a little bit of that, and then maybe we can finish it offline and push it to GitHub for people to kind of play with in their own time.
Cool, amazing. That sounds good. Sweet. So rapid coding. I will try and talk through all of the bits that we are doing in really rapid fashion. So essentially, what we have when we last left off this code is we've got on our admission review. Now, if we have a quick look into that admission review itself, if you click through to the admission review, no. If you click through to oh, actually, well, yeah, there it works in the Go docs as well. What you get in the admission review, if you like command click on, if you escape that, if you command click on the on line 15 where it says admission review, yeah, it will take you to that bit of code. That's right. So what you have there is an admission request, and you are meant to specify admission response. If you click through to the admission request itself, oh, actually, yeah, it's just a few bits down. What you have is you have the UID of the request that's come in, and you also have the object itself. Now, the object has a type of like raw extension, which is like that might as well just say interface, like Go interface. Essentially, you can cast it to the type of object that you expect. So we're going to like unmarshal it into the type of object we expect. So essentially what we want and what we expect from our mutating host, the contract that we've established with Kubernetes, is that it will send us pod objects. So we can try and unmarshal this into a pod object. So if you go back to the code itself, what I'm doing is I'm initializing a pod object, and I'm going to try and JSON unmarshal that review. Sorry, that's going to be input request object raw into the pod itself, and if that fails, then same deal here, could not unmarshal pod. So here what we have right now is the Kubernetes pod. We're probably going to have to add the import as well. So that's going to be API core v1. Yeah, that's right. Now, what we need to do now is essentially try and figure out what images are in the pod to see if there are any images that we want to like semantically modify. So within the pod object itself, if we click through to the pod object, you have the pod spec, and within the pod spec you have containers, and within each of the containers you have a container object, and within each container object you have an image. Does that make sense so far?
Yep.
So what we're going to do is we're going to simply iterate through, just like you would in standard Go if you have a slice of, well, anything really. Pod.spec.containers, and what we're going to say is let's say that we just want to take that particular container and apply any sort of patch to it.
Why
Now,
don't we just?
I mentioned.
I was just going to suggest if we detect, or why don't we just replace it with Nginx latest, just to kind of show it working? Does that make sense?
Yeah, that's exactly it. So what I'm going to do is I'm gonna create a map with our patches itself. String. If we had a bit more time, I'd probably use a proper Go struct. And what we're going to say is patch equals append patch map string. And how I mentioned, similar to how you would do like a Kubernetes style like patch operation, you have 3 fields. You have the operation that you want to do. So here what we want to do is we want to replace the image name. You have the path, which is the name of the object itself that you want to replace within the YAML. This starts at the very top level. So, just like you'd have like a JSON path, you start at the spec, and then within the containers, you have a list. This is where the index comes in handy, because we can inject the index in, and we probably want to sprintf that.
Yep.
And for the image field itself. And what we want to do is we want to set its value to just Nginx latest.
Really useful.
Does that make sense so far? Yeah, quite useful.
Yeah, I think we just need assignment. Oh, there. We can't append. This is patch map. There.
Yeah, so we need to assign it to the patch map. So that was a bug on my end, and we don't need the assignment there. So we have what we're doing now is we've generated a list of mutations. What we're saying is for every container that you see, replace this image tag with Nginx latest. Very, very helpful. And what we need to do is we need to wrap that up into a series of bytes. Send back a response. And if email, we'll deal with that in a second. Now, like I mentioned earlier, every single thing that we work with in our admission controller is essentially an admission review. Yeah, thank you for correcting that. Is an admission review object. So we're going to generate a response, which is our response review, and that's an admission v1 admission review, and that's going to be. We can copy the meta fields from the input.type meta because we want the same output to go out, and the response is going to be an admission v1.admission response, and within there the UID, which is going to be input to UID. But there's an interesting flag that you can specify, which is with the mutations that we've seen, or with the input that we've seen, do we want to allow this request to go through, or do we want to deny it? Now we want this request to go through, but with a series of patches. So what we're saying here is this request looked fine to us, but make a few tweaks, please, for us. And you don't need to specify this, but just for niceties, admission v1 patch type, JSON patch. So if they add any support for any other patch types, break. So we've now generated a response review. We need to marshal that again. So code rest flights, and we need to head. Actually, similar to what we have here. We need to. That's going to be resp bytes. Jason, this is status okay. And we've got some error handling to do here. So just do that. Could not generate patch, and could not Resp view could not generate very helpful error messages here. Okay, so let's have a very, very quick walkthrough of what we've done here. Essentially, we have taken in our input object, unmarshaled it to a pod because that's exactly what we expect. We've generated a series of patches. We have created a response set of patches. We have wrapped that up into an admission review response object with a list of patches, and we've told it that we want to allow this, but with a series of patches. And we're now sending that off into the wire.
I think it's important to note for people watching, like, the only thing that's really bespoke and not boilerplate here is just the patch that we want to apply to the manifest that has come into our admission controller. Everything else you can copy and paste pretty much character for character. You're a machine for typing that out so quickly, by the way. That was awesome. But this is where your magic happens. Whatever modifications you want to make within your controller, this is the secret sauce here. And this is JSON patch format. You can Google that. There's different types of operations and ways to work with it. I know it looks a little weird at first sight, but you do get familiar with it over time. Now, this is obviously the most useless, contrived example that we've put together, but we could build this now, and regardless of what we apply to our cluster, it is going to override it with the Nginx image. And what we need to be careful with when we deploy this is that none of our system pods or anything like that get deleted.
Yeah, and same with the hook itself.
That'd be fun. All right, let's rebuild our image. We'll delete our pod. We'll let that come back up, and then we will make a change to our debug pod, and we should see that image change from the Ubuntu one that we used earlier to Nginx.
That's right.
I'll just give Go a little second here. I guess we are pulling in a few extra dependencies now as well.
Yeah, the core v1 has got to put in a lot of Kubernetes.
So if I run get pods, we can delete pod semantic. So that's going to get the new version of our mutating webhook. What I'll also do is just pull up the logs for that here. Let's see if we get the new one. We do. Excellent. And just to show, let's describe our debug pod. We can see here that the image is Ubuntu. So, assuming I've not got my understanding incorrect here, when I delete this, a new create pod is going to be initiated and the image should be changed, right? That's what we expect to happen. Right, okay.
That's what we expect, yep.
All right, let's see. So delete, I don't need to wait for that. I'm just going to go straight into describe. We should get a new ID here. FC. Dun, 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 and it works.
Oh yes. Success.
We now have a mutating webhook admission controller making modifications to every pod in real time as they hit our Kubernetes cluster. That is awesome.
Yeah.
Not useful, but very much awesome.
Yeah.
And I wonder if that sleep command is even going to work. It is, right? Okay, it's quite happy. Nginx is probably based on Ubuntu anyway. So, awesome. Cool. What do you want to do then? Do you want to pull in the Semver library and see how that works? Do you want to pause it here and resume another day? How are you feeling?
All right, so we've got 10 more minutes till the top of the hour. Let's see how quickly we can get the Semver up and running.
All right, take it away.
So, there is, if you pull up the Chrome window, so a browser window, and we see the library I mentioned earlier is called mastermind/Semver. Let's give that a shot. So yeah, this is a library that allows us to essentially process semantic versions. And what we're going to do is we're going to use that and call out to, I imagine we want to call out to Docker Hub to see what tags are available and see if we can do some sort of reconciling with the two. So let's try and get that running as quickly as possible.
Let's cheat, right? Because we don't need to reach the Docker. I mean, we can definitely do that, but I don't think, are we going to be able to make that in 10 minutes? I don't think so. So
fair enough.
I mean, are you feeling brave? Again, you're the one doing most of the coding here. I was just going to suggest that we just provide an arbitrary list of versions and have it work against it, but I'll let you go.
Yeah, all right. Let's go with that. Let's go with that. Let's make it easy for ourselves. I think we've had enough difficulties as it is. So yeah.
Well, I think for me, the important bit is seeing how the semantic version thing will work, rather than an HTTP request to the Docker Hub. I'm happy to we can do that offline or whatever, but
yeah,
we'll see.
absolutely.
Let's just make a go for it. Let's see what happens. Right.
So if I just pull up the Nginx versions on Docker Hub, a few examples in there that are actually valid images that are going to be pulled. So we have 1.15 onwards. 1.15.
1.19.6.
Yeah, 1.19.6.
1.18.0. And let's get one more just to give us a bit of wiggle room. Let's go back a bit. 1.17.4. Yeah, we've got plenty of options there. So we can set our constraints now.
Yeah, exactly. 1.17.4. Cool, amazing. So what we're going to do is should be good enough. So what we're going to do is we're going to take the image tag that's come in, do some string manipulation to get the constraints bit, and then use that to figure out what version is best. So a little bit messy, but we're going to do all of that in this particular for loop. Now, what we want to do is, let's see, import the library first. That would be quite good.
Yeah, and I'll prepare an example. So let's assume we can satisfy. I guess we want to.
Do you have a terminal on your end? My terminal seems to have.
Oh, it's because it's running the logs.
Ah, I see. Could you go get the semver package?
Mm-hmm.
Cool. Amazing. So what we're going to do is we're going to take our image name, which is going to be in container image. I'm going to split it on the colon, and we're going to want two parts. And the image name is going to be on the left. It's going to be split.0. And the version constraint is going to be on the right. And what we're going to do is we're going to...
I've copied an example actually from there. So we'll use what they can already parse, so we don't need to.
Amazing. So that's going to be version constraint. So this new constraint is going to give us a autocomplete is still loading. New constraint returns a constraints instance that a version instance can be checked against. So essentially what we're doing is we're passing in the range to the new constraint, and then we will take we will iterate through the list of our versions and see which ones satisfy. That's done. So what we want to do is for version in version range versions, more errors for now. Don't do this in production, folks. best version as a string. What we're going to do is
do we need to loop the versions? Does that not take a list and return the best one? Is that not how the library works?
I don't think it provides a function for that version. No, it wants you to iterate through them.
All right, okay.
Cool. So what we're going to do is send the new version, which is our version. And what we're going to do is we're going to say if v if our constraint matches, I think is the name of the check. Oh, there we are. Yes, check. So what this is saying is, does our version in our version list match our constraint v? Then we're going to say best version equals version. So far, and then over here, instead of using nginx latest, sprint f intf nginx string best version. Okay, cool. I think this should be what is required. So what we're doing here is we're taking the image name from Kubernetes as it's passed in, splitting at the semicolon. Sorry, at the standard colon, initializing our constraint from there. Yeah, thank you for that. We're iterating through our version list, checking which ones match the constraint, and the one which is like the most latest, assuming that this is an ordered list that matches, will be put into the best version string variable, and then we're now interpolating that into our value. So let's give this a shot.
Do you think we should very quickly just not do anything if we get an error?
Yeah, we can probably just send an error out. So yeah, if you add one there.
I'm just thinking, like, if we want to confirm that this works, I mean, we're about to redeploy this controller, which is already going to break it potentially. No, because we have the allow failure. Okay, maybe we'll be okay. Oops.
And
just return. All right, let's build this. Let's do it.
Yeah, we're gonna.
You happy?
Yeah, I think so. I just changed the error to output it to standard out. Sorry, output it to the response.
Okay. So we're going to build this, redeploy it, and then in theory we're going to try and add our constraints to our debug container, which should be resolved for us. All with 30 seconds left. Dun, dun, dun.
If this works first time round, then that's it. It's like mic drop.
Yeah, that's it. Yeah. Just walk away with like, job done.
Yeah.
Very impressive. Okay. Delete pod semantic. So now we have a new version of our mutating admission controller running. Hopefully. Yep. So let's the reason I wanted this here is what I was going to suggest is we have this debug thing being deployed, right? Let's take a look at that, which right now is just using this. There's no colon, so I just wanted it to, you know, if it can't parse it, just to continue. So now we can add 20.04, and that should still fail, which means it should just go untouched, I would imagine. Do you agree with that?
Hopefully. Possibly.
So we can describe our pod, which is this new one here, and it should be untouched. Correct. Awesome.
Yes, correct.
Now we want to apply our magic syntax where we say nginx and we're going to say greater than 1.16, less than or equal to 1.17, which should
So I
return
think you're going to need
us,
a comma there.
no, we don't have a 116. Okay, I need to go up to 118, which should give us 117.4. So
You're going to need a comma in your, between, so more than equal to 116, comma, less than equal to 118.
That wasn't in the example. Yeah, you can just do
Oh, actually, yeah, maybe you're right. Okay.
Let's try.
That should work. Try it.
I've never been so nervous. Container creating. All right, okay. Let's see what happened. Okay, so we didn't parse this. So
could you try with the comma?
So you want the comma here?
Yeah, and also could you remove the space after the colon?
You happy with that?
Yeah, let's try that.
Okay, I think we're going to need to quickly pull out some logs. Yeah, nothing replaced. Let's try semantic. I don't think we have much going on there yet, do we? Okay. You got 5 minutes to debug while we go for it?
Yes. So is our semantic program running properly? As in, is our mutating webhook running properly? Because that looks wrong to me when you put in the logs of the semantic.
I wonder if
we
it's
actually running Nginx.
Yeah. Describe.
That would be terrible.
Yep.
Oops.
Okay, so we should be able to delete that now. Yeah, the latest version. No.
So actually, so this will work, but for a reason that is that's quite interesting. The webhook will fail because Nginx is providing garbage, and what it will do is it will just fall back and ignore the error. Whereas previously the semantic hook was correctly functioning. So if you describe the semantic pod now, it will. It should be running with the correct thing.
I think that's pulling a new Nginx. I think it's worked.
Can you describe it?
It has. Dun, dun,
oh,
dun.
yes.
And it resolved.
Success. Amazing.
Is that Siri celebrating
that
with
is
us there?
Siri, yeah, that's Siri celebrating with us.
All right, that was awesome. So, let's talk about what the next steps are. Let's finish up. Thank you very much for pretty much writing this entire thing. That was really cool to see that from start to finish. So let's assume I really want this to be a thing, right? So we want to take this code, we want to productionize. Obviously, we should add tests. And how do we ensure that we don't run into that problem we hit with the semantic controller? I guess we have to build checks and constraints into this loop here, right?
Yeah, exactly. So within the mutating webhook in Kubernetes itself, you only have namespace level constraints being added. So like saying don't call this webhook if the namespace matches these particular labels. So for example, we could add constraints that say don't run this for kube system, and we could put the semantic program itself in its own namespace and also say don't run this if in these particular namespaces or have these labels or whatever. We will probably want to add checks within this program itself to state that if the version doesn't look like a constraint range, then just continue onwards, like be graceful. in that respect. And yeah, like adding tests and stuff like that. The good thing about this is that this is a standard Kubernetes API program, so there's no reason why you can't generate some mocks and interject them as like a HTTP using a HTTP mocking library in Go. Yeah, you just pass these objects across. It's just JSON at the end of the day. You don't need any sort of Kubernetes framework or anything like that to test this, which is great.
Nice. Because we're operating on a pod level as well, we'd probably want to cache those resolutions, I guess, and memory or even on disk somewhere, because as the pods are moved around or killed or whatever, we don't want it to resolve new versions for some pods and older versions for other pods. So we still got a few things here that just make this a bit more feasible. But I'm excited, very, very excited.
It's also interesting because we may want this to run on a replica set level instead of a pod level. So imagine that you are rolling out a version of your system. Even if it is a minor version, you probably don't want an upgrade to be happening, like just because a node died, for example. We might want to say, okay, when you're ready to roll out a new replica set, and you do like kubectl rollout restart, that's the time it decides, or maybe I should consider if a new version is available that satisfies the constraints, because then at least it's human controllable. At a pod level is probably too granular.
Yeah, awesome. Well, I will push this code up just as reference for anyone that has been watching and playing along with us. I will speak to you afterwards. We'll work out how to clean this up, make a few tweaks, hopefully publish it for people to consume and test out. Happy to see my wild idea actually working. Thank you so much for just being able to explain everything that we were doing as we go so well, and for churning out all of those code, debugging, certificate nonsense, everything there. I think that was really valuable for me. I'm sure it was very valuable for others. So thank you very much for that.
Yeah, thank you, everyone. No, this was really, really fun. Yeah, and I hope this is useful. It's a fantastic idea, and I really hope that we can actually turn this into a proper plugin that people will use.
Yeah, definitely. Watch this space is coming soon, definitely.
Yeah, coming soon to a Kubernetes cluster near you.
All right. Have a great day. Again, thank you for allocating that extra time. I know we went over. I'll speak to you again soon. And goodbye. Thanks.
Yeah. Bye, everyone.